Welcome everybody to the digital version of the InfoZone presentation for Vossloh North America and Vossloh Rail Services. Many of you may know Vossloh as a company, as we have multiple business units present in North America. We are a supplier of track material and also rail services. We presented here just a few years ago at WRI and started to talk about the different technologies that we have implemented in different parts around the world and how we're trying to adapt those technologies to the North American market. And we're happy to be here today in order to provide you an update with where we're at and also future technologies that we'd like to implement. My name is Brett Urquhart. I'm the Managing Director for Vossloh Rail Services North America. I'm also here with Philip Glebe, who is the technical expert for a lot of the technologies that we'll cover. So for the digital presentation, I'll provide both of our contact information at the end of the slides in order for you to reach out to either of us with more questions going forward. When Vossloh presented 2 years ago to the WRI conference, we had some graphics on screen and we talked about the toolbox, the different tools that can be used in different applications and different rail conditions. And we are a big believer that different tools should be used in different applications. What we have on screen here is very basic. Most people in the room would understand these different technologies through different presentations in the past. Obviously, the top two, slipstone grinding and conventional grinding, are the ones that have been utilized in North America to the highest degree. When Vossloh goes out on track with any of our operations team, our engineers, we like to look at different conditions, and we really think that different tools should be used for different types of rail defects, depending on the track time you might have, depending on the depth of defect, depending on if we're trying to remove flaws or if we're trying to just optimize a profile. And different technologies can always be utilized, but they definitely provide different value add propositions depending on how they're used in different areas. When we spoke a couple years ago as well, we talked primarily about rail milling. Other companies have made presentations about the different technologies, the benefits in other parts of the world that have been widely adapted. And we had a game plan to actually roll out milling technology in this market, and in the last 2 years we have been successful in doing so. We also want to talk about the next phase of preventative maintenance, which is high-speed grinding, and we will get into more detail about that. This slide here is a little busy, so I'll walk you through it in some great detail, but if you follow the different axes here, what we're basically trying to say is that as we run millions of gross tons over these tracks, obviously we start to wear rail. In an ideal world, as these defects start to form, which is this y-axis here, we would stay ahead of everything that we do, and we would use a truly preventative technology. What we want to talk about today is we're very aware of the fact that conventional grinding has the ability to perform some preventative maintenance. It also has the ability to actually do some corrective maintenance. And we see the place for conventional grinding, but we think that there are technologies in the world that add a lot more value when we might want to get ahead of things on a true preventative measure, or in the case of milling down here, where we actually have defects because we didn't keep up with that maintenance practice, and now we've got to go in and do some corrective action. So this graph essentially is designed to show that as we run more gross metric tonnage over a certain piece of rail, we could extend the life of it the most by doing truly preventative measures like high-speed grinding and leaving a surface pattern in the rail that minimizes the growth of defects. But obviously through traffic and through track time, we don't always have that luxury. So when rail gets to a point that it truly has some type of defects in it that we can't just grind out through conventional or high-speed grinding, that's where Vossloh has looked to push for rail milling, and we can remove defects of 2, 3, 5, 6 millimeters in 1 or 2 passes, and a lot of those areas have previously been earmarked for rail replacement, or they end up being tried to tackle with other technologies like grinding, which becomes quite uneconomical. So our goal is to actually provide these preventative technologies and technologies that provide the restoration of rail to almost a flawless state. And that's why choosing the right tool for the toolbox is truly based on the rail condition that each rail track is faced with. So where are we today? On screen, you see a couple images of the actual milling machine that is in service now in the North American market. A few years ago at the WRI presentation, we were talking about the timeline of rolling this out, and we also talked about the concept in general of finding the right size of this technology that we can efficiently deploy, that we can get to hotspots, get to multiple railroads to get milling technology in front of the US market. We operate about 6 full-size milling trains in other parts of the world, but we recognize that this market has a lot of hotspots, a lot of places that we can't spark, like bridges and some high sensitivity areas. And we wanted a solution that we could tailor to this market that would get the milling technology in front of people. In due course, we do believe that the larger milling trains that have a higher output rate and a higher forward velocity hopefully will be adopted on a larger scale. But the solution that we've come up with and that we've entered into service in this market is very adaptable, very deployable, and we can actually move from track to track quite easily. So this is actually in service now, and you can see some of the images of what we're dealing with on screen. I'd like to show you briefly a couple actual examples of the type of rail condition that we're seeing in the field. Obviously, these types of wheel burns and spalling on the head of the rail is something that we just believe couldn't be addressed with any other maintenance practice. It couldn't be addressed with our own high-speed grinding, couldn't be addressed with conventional grinding. For depths of this nature, we need to come in with something that can do a significant cut depth and restore rail in hopefully one pass. In this particular example, we actually did one pass at a cutting depth of about 2.5 millimeters, and we uncovered the defects going even deeper than we had imagined. You can see that on screen here, that we've actually uncovered some flaws that were even deeper than we expected. So after a second pass of milling, we were able to completely remove those defects. What we're faced with quite a bit is when we see these types of things in the field, that this rail may have been marked to remove it completely, to actually replace the rail with new rail. And we like to think that when choosing the right technology, that we can do things at a much more cost-effective basis that doesn't need as much track time, doesn't need as much labor and crew, and we can come through and restore rail to the point that we can get many more years of service life out of it. Up on screen here are some images that most people are quite familiar with, just the different types of rail condition that we see and the things that we're trying to clean up through any maintenance practice. One thing that has been apparent to us over the last few years of actually putting technology like the VTM Compact into track is we always knew about some things like the bottom right bullet point of wooden deck bridges and areas where we can't do some conventional maintenance practices. As we've gotten the technology out on track, we're seeing a lot more areas where milling can add some value. The biggest one being replacing rail altogether. We saw some of the pictures on the last slide that we showed. A lot of different railroads may mark that for complete rail replacement. And we think that there's a lot of areas those areas that have trouble getting good test data and good readings and can't really understand the depth of those issues, but we still see some value in trying to mill those areas out. We've also seen the effect of plastic flow, and we can remove a lot of the plastic flow issues on the gauge side with one pass. And we've also come across a lot of areas that welds and bad welds, whether they're high or low, cause some wheel impacts and cause the type of issues that you're seeing on the left. So the implementation of this technology, I think, is growing in the different types of areas that we want to see it used. And I think that over time, it'll add some more value to all of the market. As we showed in that first graph, we like to take a multi-pronged approach to rail maintenance. And as we committed to bringing milling to the market a couple of years ago, and we've been successful in getting some of our unique equipment over here with the VTM Compact that we just covered, our next commitment to the market is to help improve on a more preventative type attitude on how we face rail maintenance. The next piece of equipment that we plan on bringing over in 2022 is actually this HSG City. It's our high-speed grinding technology. It requires another high rail vehicle to actually pull this along, and this will allow us to actually take readings of the track using our smart technology and also start to provide truly preventative rail care to the market. We also implement this same technology in our HSG2, which is just a larger scale version of the HSG City. And this piece of equipment can also run, just like the HSG City, in between traffic. The working speed of this is about 30 to 50 miles per hour, and it adds a great benefit of where we can implement this in different networks without having to have dedicated maintenance windows. One of the benefits that we have, in addition to high-speed grinding being truly preventative, we can grind at a high speed, we eliminate very little material as we go by in each pass, but we leave behind a surface condition which hopefully doesn't allow for new issues on the top of the rail to form. We also leave behind a unique crisscross pattern, which you can see in this picture on the right. By having this pattern through one pass or multiple passes, we actually eliminate some of these peaks that you can see are created with conventional grinding methods. And in eliminating those peaks, we actually can eliminate noise, and we actually are able to eliminate the acoustic singing that happens as a train wheel goes by. We do so by actually having the grinding wheels on one rigid beam. So you can see here on the right that the high-speed grinding method doesn't allow for the fluctuations of each grinding wheel individually. It's mounted on a 1.6 meter beam. All grinding wheels are across that in a rigid nature, so we can't have a frequency less than that 1.6 meters at any given time. This leads to good acoustic performance and lowering all noise coming out of the rail on the track. Some actual examples are given here. I'll point to them with the laser pointer of a repetitive grinding mark prior to high-speed grinding. High-speed grinding tends to take multiple passes, which doesn't tend to be an issue based on the fact that we can run in traffic. So a high-speed grinding program would actually require multiple passes, but we can usually do that within a single shift. You can see after the first pass, the old grinding marks are still there in the middle. You can see after the second pass that they start to be eliminated, and we can see after the third pass that any old conventional grinding marks are gone, and we've left that crisscross pattern in the rail, which again helps us not to form new issues on the railhead and also improves our acoustic quality going forward. This data on screen here is a third-party acoustic performance test of looking at high-speed grinding versus other methods. We'll be the first to admit that the oscillating slipstone grinder does actually provide the best performance out of the gate, but we're quite aware that economically it doesn't have the performance to actually, be highly chosen in the market. So we have compared all of these differences to 4 different types of conventional grinders from 4 different providers. And what you'll see is that the high-speed grinding actually places this pattern into the rail, and because of the fine nature of that pattern, after smoothing, after a week of traffic, the high-speed grinding pattern that's left behind actually smooths almost to the same acoustic performance as a slipstone grinder. One of the next things that we're very excited about in using high-speed grinding technology is the coverage that we get of different networks. With the first high-speed city system that will be introduced in 2022 into the North American market, we plan on equipping it with what we call Vossloh smart technology. This technology actually allows us to take readings while we're performing at a high speed in order to then tailor our grinding program for future passes. Additionally, these readings can help us to see where our client should be using conventional grinding methods and where they should be using milling as alternate technologies. So our readings that are done in real time can actually create a grinding plan like you see on screen right here. We do this with 2 simple systems, a cross profile system and a longitudinal profile system. I'm sure everyone is aware of these types of readouts, but as I said, we're very excited to implement this into the machine that will come into this market, as it will help people understand more about their programs and where we can do more preventative measures, or where we need to come and actually conduct some corrective shifts if we see defects in track that can't be addressed with any type of grinding method, and we have to come in and provide milling services as an alternate. Hopefully this presentation gives everyone an update on where we are in the market. As stated earlier, Vossloh truly believes that we should be choosing our maintenance practices based on the rail condition that we're faced with, and we believe it's our obligation to continue to bring these different technologies to market so these options can be available. We believe that we've had a successful start in launching a practical approach to rail milling in North America. We're committed to bringing our high-speed grinding technology and our smart technology to the market in the coming year. For those of you that are just listening digitally, we provided our contact information on screen. If you have any more technical questions, you can gear those towards Philip, and I'll do my best to also reply and get you the answers that you need. Appreciate everyone listening. Sorry for those that couldn't be here in person, but we absolutely look forward to seeing you guys again soon, and hope you have a great day. Thanks.